Yes, hello everyone. Good afternoon, all of you. Santosh, Maria, Jimmy, Runal, Shyam. Yes, so
Good afternoon, sir.
afternoon, Amit. Today we have this COA unit number 2. So we are going to wind up with this unit. Unit 2 we will finish today. Okay. Yes, Michael. And next class we will start with unit number 3. Okay, so this is our target. We have the last topic remaining in unit 2 which we are going to finish today. Fine. So let me share the screen now. And yes, all of you can write your numbers as you are doing here. ID number, write it down for your attendance purpose. Okay. So I am sharing the screen. This is visible. Yes. Shall we start?
Yes, sir.
Right. So this is your session number 16. So far, I think around 45 to 50 sessions you will require. Okay. We have completed with registers last class. So all of you are familiar. You have taken some example. You have drawn it by yourself also, right? So anyone has a question related to registers? Any doubts? Anything you have? Or can we proceed? Please respond. Any questions? Any gaps are there in the last class? Any doubts? Anything? Yes. Are you all listening to me? Am I audible? Clear? Yeah, that's good.
Yes, sir.
Yeah, you speak up, then only I can know because the screen is full screen. That's why. Okay, that's good. So register is over. Now we'll see one more category. As I told you, we have started with multiplexers, then we have seen registers. So the last part, that is counters. Okay. So today our topic is binary counters, and you are going to learn today that is what is counter and what is meaning of a parallel load in the counting. Okay. So we will finish with this topic, and this is the last one. So with this we will finish the unit number 2. So when you come in next class, what you are going to do, just revise all the things I have done so far in unit number 2. Okay. So all the slides are already shared with you. Go through the slides and we are going to have a test. First 10 minutes. As usual, what we are doing, right? In starting, first 10 minutes I will give for taking the quiz. And after that, we will start with the new unit. This is all about instructions. What are instruction code in different language and so on. Okay, fine. So let's start with the counters. Here is the binary counter circuit. But before I explain you this one, first you should also know the significance of which circuit is useful at which place. Okay, that is important. So when you see the word counters, what do you assume? What is meaning of counters? Where the counter can be used? Is there any real life application where I can use counters? Can someone speak up, please?
When we want to count things or how many things you have, sir.
It's all about counting, right? You have automatic counting. So maybe you are, suppose you take example of airport. So how many passengers are coming inside the airport? How many are going outside from the exit gate, right? I just want to keep account that we want the statistics, right? So in our airport, maybe we want to say that every month 15,000 passengers are coming and boarding. So this is one example. Which other places we can use counters? I'm talking about automated counters. Wherever you use automated counters, this is the inside circuit, right, that you should be aware of, that actually it is built by using this type of logic. Okay, so that's the logic we are going to see. But before that, let us find out some applications where we are using counters. Yes, Umang, you need to join on time, Umang. Okay, everybody has already joined. So counter application, if you want to see, all of you know there is, we are using microwave oven, right? What we do in a microwave oven? Is there a counter?
Warm things up.
Yeah, who so?
Yes.
Do we use counter for that?
Yes.
Yeah, digital clock, very good example Mansoor has given. In your digital clock also, you see 05, then 06. You go to railway stations, usually in India, when you go to railway stations, you find the clock, right, which will show you the platform number and what is the current time. So for that also, they are using counters. Right? In washing machine also, yes, obviously. Mostly, see, it is washing machine or any utility electronics, right? It is microwave. You have reverse counter. Suppose you set to, even we have trouble like we want to switch on the motor, right? And after 10 minutes we forget to switch it off. So what we do? We place a counter circuit. It will count 10 minutes, 9, 8. When it becomes 0, automatically it will trip and it will switch off the circuit, right? So many such counters, they are available in real life. Okay, so how the counters are working, what is the basic circuit of counters, that's what we are going to see today. Okay, but yeah, I will show you some examples where we are using it, because I got one folder, I think. Let me search it out. Because I have listed out many applications, yeah, of the counters. Yeah, you could just see this. You see the 4 examples. Wherever there is a timing or timer circuit, we will be using counters. Right? This is one example. Use it in microcontrollers. Right? Usually in industry, this is an example of an industry where they will have a switches like this, power on and power off. Right? Then switch on the machine for 5 hours or 4 hours, 3 hours. So you just have to click on this. Automatically, this is a stop timer. Right? After 4 hours, it will stop. Even in your air conditioner, I think all of you know this. Right? This is LED time, microwave, washing machine. You see on the front side of washing machine, you have timer, right? 10, 20, 30, 50, like that. So you can rotate. But physically, when you rotate, what happens? This is the inside view of your washing machine, okay? This rotate, when you rotate, what happens is the value of your potentiometer will change. And according to that, it will set the time. Okay, so it's like chip select. All of you have seen what is meaning of chip select, CS, right? So there is 10-minute chip, 20-minute chip, 30-minute chip. Whichever you select, this is button which is chip select. Okay, so you rotate, based on that, it will perform the operation. Okay, so these are different counters. You want to learn little more, there is one exercise for you, that is Tinkercad. I think maybe I have mentioned this earlier or not, I don't know, but there is a Tinkercad application which is online on website, web based. Okay, here you can create any type of circuit, electronics, there is electronics. You can create, put a breadboard, create the circuit and see how it functions. If it is successful, you can purchase those circuits also. It is not costly. You can prepare a timer or stopwatch by your own also. Okay, so yeah, you can just note down this one. The name of website is Tinkercad. If you want to explore more, you can go for this. All right, now let's come back to our daily routine circuits. If you see here, you find lot of resemblance with the other type of circuits. Like if you try to compare this with multiplexer, or you compare with resistor, do you think it looks little similar? Yes. What are the similarities you see in this counter circuit if you try to compare with a multiplexer or resistor? Yes. Can someone reply, please? I'm not able to hear the voice. No one is answering. What happened?
Sir, I want to answer, but I don't sure it's correct or not.
Mansoor, I think I have some network issue. I'm not able to listen. You can just put up the chat message, or let me switch off the camera. Yeah. Can you speak one more time, Mansoor, please? What you were telling? Mansoor?
Sir, I want to answer, but I don't know it's correct or not.
You can say, no problem. Just put a guess.
So there, I also see an enable, which was in the
That
multiplexer.
enable switch is there, common enable switch. Okay. Then there are 4 registers. You use 4 flip flops, right?
Yeah, for D flip
But
flops.
yes, there is a difference. We use 4 flip flop. In that we use D flip flop, but here for the counting purpose, I use JK flip flop. Okay. See, it is up to the
Yeah,
application. What type of application you have? You want good results for counting, then JK is better. Okay. So instead of this D, we are using JK flip flop. You have a clock signal here always. It is by default, right? And you have count enable here. What is count enable? You got AND gate, and output of each, you see, output of each goes as the input of next. Yes or no? The output of B0 goes to input of B1. Output of B1 goes to input of B2, and so on. After B3, you get the output that also you put AND. Okay, with this count enable, and then you get the carry. All of you know what is carry, right? You get an extra bit which we want to ignore, so that is carry bit. So this is how binary count looks like. What is the purpose? Again, let me tell you what the counter will do. It will count the values, right, from 00000 to 1111. Now, how does this behave? This is an example of 4-bit synchronous counter by using JK flip-flop. Okay. Now, how does this operate? Let me show you how this is operating. Initially, it will be, try to see the circuit. The initial value is always all zeros. You start with all zeros, right? So the first value will be 0000. Now what happens is, you just see when I do clock enable, what happens? Clock is enabled here. It means the signal is 1. But this signal is, what is the first signal? Clock is enabled, right? So both the values are 1. When both values are 1, what happens? Do you remember? When both value of JK is 1, what happens in the output? Any answer? Yes, guys, all of you are with me or not? Again, there is silence. What happened? See.
Sir?
Yes. You able to see everything perfectly without any
Yes, sir.
disturbance? Yeah.
Yes.
So, what's the use of counter? That is my question. So, what actually happens is, initially the value of B0, you have here B0, B1, B2, B3. So, initial value is 0000. When you start the counter, what happens is it becomes 0001. It is counted. You know what is meaning of counting, right? So it becomes 0001.
Yes,
Then
sir.
it changes to 0010. Then next time if you give the signal, both the signals are high. So it is 3. So this way, then next value is 4. 01, 01. So that is 5. Then 01, 00. That is 6. 01, 01. There's a mistake here. 100, 101. Then 111. 110. 111. And so on. Okay, so this way it goes. Incrementing the value. This is nothing but it is 0. Equivalent value of 0. This is equivalent value of 1. This is, pick up now, please. What is this value? 0010.
That's 2, sir.
That's 2.
It's 2.
And next is 3. Yeah. Then comes 4. Then comes 5. So this way, in the same sequence, the counting is being done if I use this type of circuit. So actually, you know, I am designing the circuit in such a manner that it will generate the output in this style 0, 1, 2, 3, 4. Got it? And
Yes,
yes,
sir.
finally output is C. Input of first is goes to second, second goes to third, and so on. So the last one, again one more AND gate. Total how many gates we are using?
4, sir.
See, I can ask you indirect questions also, that how many gates are used in binary counter. So 4 AND gates and 4 flip-flop, JK flip-flop, right? You have got how many input and how many output, please? How
We've
many
got one
input, how
input
many
and
output?
one
Only
output.
one input. That is, this is, you know, this is something like this input you see here on the left side. This is like a
Yes, sir.
next value. Show me the next value, just like a button. So when you click on next, the new answer will be generated automatically. That will be the next value. To try to convert, that will be the next decimal value. Okay, then I click on next, one more value will be generated. Now, yeah, there is one question I think you should ask. If everything becomes 1, 1, 1, 1, and then I put next value, what do you expect? Tell me.
Sir, ask the question again.
If I have, finally what I will get is 1, 1, 1, 1. All values are 1, the highest capacity. Okay. Now I say count one more time. I don't have any memory available now. Again I enable count. What will be the next value after 1, 1, 1, 1? What do you expect? What it will become?
Mm,
Any guesses?
1, 1,
It
1,
is
1.
intelligent. Yeah. It starts from 0, 0, 0, 0 and it goes up to 1, 1, 1, 1. Right? After that, if you add one more value, what will it do? What do you expect?
I think to get back to 0, 0, 0.
Yes, exactly. Okay. So it's like a cycle. You finish the task, no capacity is there, it will again jump back to the normal state. It will start with 0, 0 again. Okay. So this is how the counters will work. Fine. So just now I have shown you, this is the sequence. This is 0, and next is 1, the next is 2, next is 3, up to all 4 ones are received. Now, if I ask a general question that I am using a binary counter with 5 by using 5 flip-flop. Just listen to the question carefully. I use binary counter with 5 flip-flop. Then up to which value I can count? Tell me the answer. The counting is possible up to how many values total? Can you give the answer? This is a very simple question.
Isn't it 4,
32.
sir?
Very good.
Oh.
2 to the power 5. What is 2 to the power 5? 2 to the
32.
4 to the 8 to the 16 to the 32, right? So if I have 4, how much I have? 16. If I have 5 bits, it means it will be 32. So it is up to you, right? I have a washing machine and I want to give maximum up to 30 minutes, 1 minute, 5 minutes, 30 minutes, how much? Then how many JK flip-flop I will use? 5 flip-flop. You got it? You try to map this with a real life scenario. Okay. Now if I ask you, I want my motor, right? It should have maximum in terms of hours, 1, 2, 3, 4, up to 24 hours. I should keep the motors on, right? So 1 hour, 2 hour, up to 24 maximum, right? More than that, we don't have more hours. So in this case, how many flip-flop you will require for designing the circuit? Can you suggest? For 24 hours, how many flip-flop will be required for the binary counter? My easy question, simple question. If you try to get my question. Did everyone get my question? What I'm asking? Yes, please.
Yes, sir.
Yeah. Only Wuso is replying. What about others?
Yes, sir.
Yeah. So try to give the reply then. Will I write the situation here? What I have is 24 hours to be set by using counter circuit. If I'm using counter circuit, my question is how many flip-flop are required? Give me the answer. Yes, who can give the answer? If I use 1, it is 2 to the power 1. So 2, 1 and 2. Only 2 hours I can put. If I put 2, then I can use 4 hours. This way you have to find out where you can use 21. So up to what you can accommodate this number, 24. Yes,
5 flip-flops.
you use 5 flip-flop. If you say 5 flip-flop, the answer is 2 to the power of 2 raised to 5. 2 raised to 5 is how much? 32.
32.
Right? So fair enough. Means I can set up to 32 hours. No problem. There is something extra we can understand. Okay. So 5 is fair enough. What about 4? Yeah, Michael,
4 it is.
we cannot have 4.5 here. Okay. Because there is nothing like point. When I say either I want 1 bit or I say either I want 2 bits. I cannot have 1.5 bits. That is not allowed. Right? How you can have it? So if I use, suppose, if I use 4 flip-flop, 2 to the power 4, power of 2, 4. What is it? 16, right? Will I be able to suffice my requirement? Only 16 hours? No. So that's why
No.
this is considered as the correct answer. Okay, even though it is more, but yes, we can use that. So 5 flip-flop I have to design in my circuit if I want to set this 24 hours timer circuit into some application, real life application. Okay, I want to control the motor of my company, something like that. Then we can do that. All right, so this is an example of 4-bit synchronous counter by using JK flip-flop. Now new word is coming to you. What is that? Synchronous. Till now you did not see synchronous, right? So there are two things, synchronous and asynchronous. What is that? Okay, so this is how the working is done, right? 0, 1, 2, then last values will be 7 and 8, and this keeps on going. So this is because of your AND gate logic. It will generate this type of output. Okay. Now coming to this synchronization work. So there is a binary counter with parallel load also. What do we mean by parallel load? See this example. The flip-flop can change its state by using either positive edge trigger or negative. I think, did I explain you before what is positive and negative edge? Yes or no?
Yes, sir.
Yeah, already you know this, right? So it is leading. I also give another name, rising or leading edge. And this is falling edge. So it comes down from 1 to 0. So that is falling. So now if I use a counter, I have to decide. I want to count when it goes up or I want to count when it comes back. Okay, which place I want to count, that I can decide. So this is known as example of binary counter with parallel load. Is there any one unmuted? I can see a little bit of voice. No. Okay. Fine. So what it says, the flip-flop can change the state either on positive edge or on negative edge. So in synchronous counter, count on the rising edge, which is low to high of the clock signal, and asynchronous, we also call it as a ripple counter. Okay, it is on the falling edge. You got the point what they want to say here? I will come back to the circuit. If I say that this is a clock, you see the clock at the end of this diagram. This clock
Yes.
goes up. When it goes up, this signal is activated, and here I get the change. The new value will be shown here. It will blink here. Okay. When it goes down, nothing will happen. The next clock, when it goes up, again the new value will come. Okay. So it works like this. Let me show you step by step process. See, I have a clock. It goes on like this: 1, then 0, then 1, then 0. It's continuous. Right. So your value, when it will change, it is 0 right now. When your clock value is from 0 to 1, when it becomes from 0 to 1, it becomes 1. Okay. From 1 to 0, it remains as it is. From 0 to 1, it becomes 2. From 1 to 0, are you getting my point what I am doing here?
No, not really, sir.
I will write the notation also. So first thing, remember, I will draw like this: 1, 2, 0. Copy this. Signal of clock, it is always 0101 alternate. All of you agree with this?
Yes, sir.
Yes, sir.
Because you see, I have shown the symbol here. No, the symbol representation I'm showing you live. That actually inside the machine how it operates. So this clock symbol 0101 rectangle, that rectangle is nothing but the value. So values goes like this. It becomes 1, and after some time again it becomes 0, then again 1. This is a square wave. We call it as a square wave. Okay. What about the counter? Means there is any counting done? So initially the counting is not there. When you give clock signal as 0, will it count? Yes or no? That's my question. Give the clock whose value is 0, the counting will be done or not? Yes or no?
No, sir.
No, right? It will be as it is. But when you move from 0 to 1, this moving from 0 to 1, this is known as what? Just now we have seen.
Rising edge.
Positive edge triggering means leading edge. You are increasing the value, right? So that is called leading edge. So always the leading edge, we will change the value. So now in the leading edge, it becomes what? 1. Now is it clear? Now it is falling edge. So what will be the
Yes,
value
sir.
in the falling edge?
0, sir.
Please remember, it will not go to 0. It will be the old state only. It will keep the state as it is. Means it will not change. Okay, it doesn't go back to 0. This thing please remember. So it doesn't make the change in value. Now again from 0 to 1. So what will come here?
Increase by 2 to
Increase
2.
by 2. Yeah, increase to 2. Is there anything like 2 in binary?
No, sir.
Actually, that
No,
is not
sir.
true. It is 1 0. Okay. But just for our understanding, we can say next value, that is number 2, equivalent of number 2. What happens from 1 to 0? This is known as,
It maintains the 2.
this is known as which type of link? Going from 1 to 0? Which
Falling.
edge? Falling edge. So when you are falling,
Edge.
yes. When there is falling edge, don't do anything. Now there is rising edge. See, 0 to 1. So now we refer to new value. What's the new value?
3.
3. Yeah. So it will remain because this is falling. So let it be 3. Now again from 0 to 1. So new value. So 4. Then continue with 4. So this is the manner in which the counting will be done. Ultimately, we are doing counting, right? So when it rises, I get the count. When it goes down, the count is being preserved. Preserving is also very important, right? What happens? There is preservation of the value. If you don't preserve it, then how you can use for the next value, right? So that's why we use this leading and trailing edges. And as it is mentioned here, in which situation we are using it? So when you use this rising edge,
Binary count.
yes, in binary counters we are using, but when you use as a rising edge, right, it is known as example of a synchronous counter. It is with sync, right? From 0 to 1, it is logical, but from 1 to 0, if you are putting, it is something like reverse. Okay, so we call it as a ripple or reverse or asynchronous counter. Is anyone added? No. So is this clear? Difference between synchronous and asynchronous? When there is rising edge, it is called synchronous. When there is falling edge, we call it as a asynchronous. Now, I will come back to this scenario, same scenario. Okay, the counter which I have shown you over here. This is an example of. Can you tell me which type of counter? Is it synchronous or asynchronous? It
Synchronous.
is synchronous. Now the same counter, if I use here as an asynchronous counter, what will be the change in the counting values? Can you suggest? If you got my logic, I think, yeah, you can tell me what is happening.
Sir, it will start from
What
0,
will be the
1.
value? It starts from 0, right? And from 1 to 0, you are falling. Right? You are falling from 1 to 0. So at that time, value will be what?
1.
It will be 1, yes. So for falling, it is 1. For rising, it remains as it is. And for falling, it will be 2. Rising, it is as it is. Here it will be 3, 3, then 4, 4, and here it will be 5. You see the difference here? At the end,
Yes,
what
sir.
you are getting, it means which circuit is more fast. You see which circuit is more fast. Here I am getting value 4.
The
Here I am getting value 5. Yes, sir, correct. Asynchronous circuit, it is more fast. Right? So again, it depends which time you are starting. Suppose I start from this time, then both circuit will be same. If I start with this time, then asynchronous is faster. I am getting the output more fast compared to this circuit. Okay. Okay, so this is about functioning. Let us go through a little bit what it is written over here. So what is meaning of binary with parallel load? Parallel loading is often a required capability. We require this situation, right? When we use synchronous clear. When the clear is 1, all the input will become 1. So it clears all the flip-flop. Okay, I have given the example of 0, but what about 1? We did not talk about 1, right? If I put 0, the value will be 0. But if I put 1, what happens? All the input are 1. So it will clear your flip-flop. Okay, so it's up to you to decide which digit you want to use, either as 0 or 1. Now, so this is just to clarify, if I use 1, I am using, you just want to disable, right? The count operation, parallel load. So 1 means parallel load, 0 means not parallel, that is synchronous load. Okay, or you can also say reverse also, it is up to you, right? 1 means leading edge and 0 means trailing edge. Okay, you can decide by your own. And yes, always remember all the values of input in register, they are always incremented by the value 1 only. Okay, there is not direct increment like +2 or +5 or +20. That is not possible. Okay, just a single increment from previous value we jump to next value, only single increment is there. Okay, so this is all about the binary counters. Now we have time, so what we can do is just go through the circuit, and as usual, but today let us do one thing. I need to nominate someone, because every time only 2-3 people are doing, that is not fair enough. So for today, Angela and Sagar and Darshan. Okay, I'm writing the name Angela, Sagar, and Darshan. These 3 people should keep the pen and paper ready and prepare this diagram so that they can remember. Just for 1 minute 60 seconds of time, I'm putting this on over here on the screen. Please read it out, try to remember this, and then you can draw it and show it to me. Okay, please respond, all 3 of you.
Okay, sir.
So that is Sagar, Angela, and Darshan. Please reply. Yes. What about Angela? Okay, done. Yeah. So here we go. I give you 1 minute. But everyone, yeah, everyone, please go through this. You will also get the chance, because everyone has to remember, right? Please go through the circuit. Then I will ask someone from the class to verify also that what is the mistake. Everything is correct, or is there any mistake? Go through this quickly. You won't find much differences, right? 4 flip-flop are there in register also, multiplexer also, counter also. Yes, so I am holding this on for 1 minute. All of you, please check the message in the WhatsApp group about the OW details. Okay, so don't forget to complete the task.
Sir, one doubt, sir.
Yeah,
Sir, sir, in that message, ma'am talking of 12105 roll number.
12105.
Yes, sir. But we started from 180.
182. No, this is 182 up to, from 182 1 is there, and another is up to 218, right? From 182 to 218. So one group 182 to 179, right? One group is under Radha ma'am. Both the groups separate images are there. You just see where is your name. Okay.
So, sir, we have to join at 11 o'clock or 12:30
You have to join for what?
for the webinar, sir.
Webinar, where it is mentioned, I don't know. This is for your OW. This is your OW task. Okay. And yeah, for the registration, 11 to 12:30 is the time. Yeah, 19th December, 11 to 12:30. Web designing, we are asking, right?
Yes, sir.
Yeah, that is 11 to
Sir,
12.
ma'am mentioned there's a 12105 roll number have to join at 11 o'clock, and rest of have to join at 12:30. Ma'am mentioned there, sir.
Timings for roll number 12105 for rest. Okay, okay. Oh, I will check with her. Okay, you'll get the updated message. Just wait. Your roll
Okay.
number is different, right? Okay.
Yes, sir.
Okay, we'll do that. You just check this diagram, everyone. We'll discuss that later. Okay, I've sent it. You will get the update. I think this is fair enough time. All right, now let's see who is ready. Angela, Darshan. All three of you are ready? Yes, please. Switch on your camera. Darshan, Sagar. Doing? Switch it on. I want to see. Darshan. If you have done partial, then also it's okay. Let us see how much you are able to do. Please show the current status, Darshan. Yes. Yeah, good. You start from the top, then you put here enable. Okay, so the enable is there, which is already joined with J and K both. This is a special case. Okay, so the first bit it is joined with J and K both. That is enable. Then whatever output you get, and this enable signal. So when I put enable signal, 2 bits are already controlled automatically, right? So pass it on, then pass to third, third to fourth, and fourth to outside. There is one more AND gate. Just go down. I want to see, or is it still mixing? Okay, okay. You continue with this diagram. Try to finish this. Going good so far. What about Angela and Sagar? Yes, Angela and Sagar.
Yes, sir, I am ready.
Ready? Okay, good. Keep it on. Angela, now you be ready, okay? Angela, are you listening? Okay, so here we go. Now I want Michael to comment on this. Michael Chikoba. Is this a correct model? Anything missing out?
So I cannot see it correct.
It's not clear,
I
yeah?
cannot see it. Yes.
Just wait for a while. The image is not clear. It is little blurry still. Hold on little stable, please. Sagar, try to hold on stable. Don't move, please. No, it's difficult, okay. Yeah, but it seems I think you have drawn. I can see 4 AND gates are there and 4 JK flip-flop are there, 4 output and 1 enable input. So I think, yeah, everything is there. Nothing is missing. Good. Let's see what Angela has done. Angela. Angela, you are not replying. What happened? Okay, guys, so with this, we are finishing up with unit number 2. And the next class, what we are going to do? Yes, please. Respond, please. Unit 2 is over. So what next?
Just then unit 3, sir.
Test, yeah.
Hello. 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 Am I audible?
Yes, there was connection issue. You are not clear on the type of flip-flop, Michael. Okay, let's see. You can have a small revision, 2 minutes revision, what you are telling. Because I think, yeah, most of the other people, they must be familiar. Let us see that. So flip-flop, when we say, there are different categories. What are the categories of flip-flop? Can someone name it, please? Yes. What categories? Today you have seen, already today you have seen. What was that example of? Just now you have seen the picture.
You mean the JK flip-flop,
Yeah,
sir?
that's what. JK is one. What is other type?
SR flip-flop.
R
Sir,
or RS.
toggle, sir, toggle.
Toggle. That is T. And
Yes,
one
sir.
more last. One more is there.
Sir, delay, sir, delay.
D flip flop. Yes. So see, these are two categories: JK, SR, T, and D. Four different types are there, and it depends that whether I am putting the trigger on the positive edge or on the negative edge. Just now we have seen this, right? So that is known as edge triggered flip flop. So positive edge triggered. See, I can say like this: I have positive edge triggered RS flip flop. I can say SR or RS, it's same. Okay. Or I have negative edge triggered D flip flop or positive edge triggered JK flip flop. Okay. So edge triggering is a process, but the trigger types are this only. Is it clear now? Now, what are the rules inside this? Again, these two are same, these two are same. Okay. These two are two input flip flop, two input, one output flip flop. And this two is one input, one output flip flop. Okay, so that is one difference. Another difference here, we have got some problem which is known as race condition, right? If you remember, because of both the values are one, what shall I do? So that condition, it is known as a race condition. But this type of condition doesn't happen in RS flip flop. What we say in RS flip flop, if both the values are one, what I will do? Remember the word toggle? Yes. So if
Yes,
both
sir.
values are one,
Both
when
are
my
one, it is
old
not
output is
determined.
zero. Yeah, it is not
Yes,
determined.
not
So my
determined.
old output is zero, I will change it to one. Okay, or if old output is one, I will change it to zero. That is known as toggle. Whichever value, old value, just change it, because if you are confused. Here it is fully confused, so you don't know what to do. But this is the idea given, right? So this is intelligent. This JK, it is not intelligent. It is old one. Same way here, T flip-flop is very simple one, but you want perfect delay, then you use D flip-flop. Okay, so D is better, RS is better. So good, you want, now I ask a question. I want a good quality single input flip-flop. Which one I will use? Good quality single input. Then I go for D flip-flop, delay flip-flop. Right? Someone has given the message. Okay. Another question. Suppose I don't want to bother for the quality. Okay. Means okay quality. I want two input okay quality flip-flop. What is that? Yes, please reply. Two input okay quality flip-flop. Which one is it? Yes, JK.
The JK.
SR or JK?
Yeah, JK is okay. JK is okay. And SR means it's good. Okay. Same way, K is initially invented, but with better design, that is D. All right. So let us stop for today. So this is all from my side. And the last 1 minute, 1 or 2 minutes, we can spare for summarizing what we have done today. So Mansoor, can you do that? Mansoor, are you okay with it? Mansoor, please reply.
Yes, sir, a little bit.
So please summarize what we have done for today.
Today we studied the counters, binary counters,
Yes,
which
exactly.
is sequential circuits, and they use flip-flops in themselves or in the circuit, and the flip-flop is JK.
Yes. Yeah. And we have seen two words, that is synchronous and asynchronous also, right? Okay, I will ask
Yes,
Amit
sir.
Kumar. Amit Kumar, can you tell me what is the difference between synchronous and asynchronous counters? Preet, what happened to you? You keep on joining every time. Yes, Amit, please reply. Difference between synchronous and asynchronous counters.
Sir, I forgot, sir.
Forgot. You remember there is something called leading edge and trailing edge? That you remember? Amit, today you are
Yes,
not
sir.
able to concentrate. What happened? You remember leading edge? What is meaning of leading and trailing edge? Yes or no?
No, sir.
No. Okay. So it means I think today you are not able to concentrate. What happened? I don't know. Preet, when did you join, Preet? Network problem. Okay. Maybe, but did you listen to the lecture? Then give me the reply. What is meaning of leading edge and rising edge? Preet, there are two type of edges. Do you know this? Did you listen to this? Yes or no? Okay, Deepak Kumar. What about Deepak Kumar?
Sir.
Yeah, just wait. Also, I want to check if Deepak Kumar knows. Deepak,
Yes, sir.
do you know the meaning? Two type of edges going from top to bottom and bottom to top. What is that?
Sir, I only know about that asynchronous and asynchronous. The asynchronous is faster than asynchronous. You will
Right.
tell that one to four in asynchronous and a 1 to 5 I think in
No, no. See,
asynchronous.
you don't see that number. That number is just for the counting purpose. Actually, jumps from when the change is done. That is more important. Okay, it jumps from 0 to 1. It is called what? Positive or negative? Going from 0 to 1, it is called what?
It is positive.
Positive trigger. right? So positive, it is synchronous, and negative means it is asynchronous. That is how you should remember. Okay,
Okay, sir. Thank you.
fine, yeah. Okay, then all of you can leave now. The class is over. Okay, bye bye.
Thank you, sir.